Hello learners, welcome to this course on Embedded System Design using AT89C51 microcontroller. In this tutorial, I will be describing about on how to interface an LED with microcontroller. So LED is a light emitting diode, which is a simple optical source which emits light at different wavelengths. And red LED will emit at 650 nanometer, a green LED will emit at 450 nanometers. So we can find this LED in different electronic appliances. So mainly it is used for the indication purpose, whether the electronic device is working or not. And nowadays the LEDs are also used for displaying characters, digits and symbols. So LED is a simple two-terminal device which has an anode and a cathode. So we can connect the positive terminal of the battery to the anode and the negative terminal of the battery to the cathode. So we can connect a resistor to this LED, thereby we can limit the current passing on to the LED. So a minimum of 1.2 volt given to an LED will make the LED to glow. In this tutorial, I will be describing about how to interface an LED array with AT89C51 microcontroller. So the microcontroller has 4 ports, 8-bit ports, port 0, port 1, port 2, port 3. So I am going to take 2 LED arrays. One connected to port 0.0 to port 0.7. Another one connected to port 2.0 to 2.7. So here I show the circuit diagram of our project. So where we connect our AT89C51 microcontroller with the oscillator circuit and the reset circuit. So here I connect a 10 MHz crystal connected to XTAL1 and XTAL2. And this crystal is also connected with a capacitor to stabilize the clock frequency. And we connect a reset circuit to the reset pin of your microcontroller. So this reset is a logic high pin. So by default, this pin will be at logic 0. Whenever I close the switch, what happens? There is a voltage drop across this capacitor, thereby it will go to reset. So this is the minimum circuit connection required for our microcontroller to work. So we need to connect an oscillator circuit and a reset circuit. So in addition to this minimum circuit, we can connect our peripherals, input or output devices depending upon our application. So here I have connected 2 bar graph LEDs where pin number 1 to 8 represents the anodes of the LED and pin number 13 to 20 represents the cathodes of the LED. So we have connected 2 bar graphs LEDs. The anodes are connected to the supply voltage, whereas the cathodes are connected to the port lines. So an important thing to note here is port 0, it does not have an internal pull-up. So thereby we need to connect the pull-up externally so that I can use this port 0 pins as a normal input or output pins. Whereas port 2 has internal pull-up, so we need not connect an external pull-up here. So this is because in port 0, it can be used for interfacing your external memory. So external memory of size 64 KB can be interfaced with our microcontroller. Since it is 64 KB, we require 16 address lines. In that 16 address lines, the 8 lower order address and data are multiplexed in port 0. Whereas higher order address lines A8 to A15 is available in port 2. So in order to use this port 0 as an input or output port, we need to connect an external pull-up resistors. So I have connected 8 pull-up resistors here with a value of 1K. One end of the resistor I connected it to supply and the other end is connected to the port pins. So by default, this port 0 and port 2 will be at logic high. So when I want my LED to glow, we need to send a value of 0 to port 0 and port 2. So thereby the corresponding LED will glow. So a logic 0 to the port pin will make the LED to glow. A logic 1 will switch off your LED. So now let us start with the programming part. We will be using an embedded C program. We will be developing this program in the IDE called Micro C Pro for 8051. So after writing the program, we convert this program into an hexadecimal file. Then we import that hexadecimal file onto the circuit built on a Proteus 8 professional software. Then we will try to check the logic. So first let us create the circuit. So here I show a circuit where I have interfaced the oscillator circuit, reset circuit with our microcontroller. Then I have interfaced two bar graph LEDs, one green color LED bar graph LED, another one is red color bar graph LED to port 0 and port 2 respectively. And in port 0 I have connected the external pull-up resistors. Then we go to Proteus. After completing the circuit in Proteus 8, we try to write an embedded C program in Micro C Pro for 8051. So here each C program will have a main function. So inside that main function I define an infinite loop. So while of 1 represents the code is going to get executed infinite number of times. Since the condition is always true, this small piece of code will get executed infinite number of times. So in this code what we do? We put port 0 equal to 0x00, which means port 0 has 8 zeros. So zeros will light up your LED, 1 will switch off your LED. So all the LEDs connected to port 0 will glow. Same way in port 2, I specify a value of 0x55, where this 0x represents it's an hexadecimal number. So 0x55 means it is 01, 01, 01, 01. So which means the LED connected to port 2.7 will be on, 2.6 will be off, 2.5 will be on, 2.4 will be off, 2.3 will be on, 2.2 will be off, 2.1 will be on, 2.0 will be off. So in order to retain this value for some time period, we invoke a library function called as delay underscore ms of 1000, which creates a 1000 millisecond delay. After this 1000 millisecond delay, we change the logic in the port. Port 0 is assigned with 0xFF, which means I have 8 ones. So all the LEDs connected to port 0 will be in off state. And port 2 I am assigning it with a value of 0xAA, which means it is 10, 10, 10, 10. So which means the LED connected to port 2 7th pin will be off, 6th pin will be on, 5th pin will be off, 4th pin will be on, 3rd pin will be off, 2nd pin will be on, 1st pin will be off, and 0th pin will be on. Again I want to retain this value for 1 second. Then since this small piece of code is available in while of 1 loop, it runs continuously. Once this program is done, we need to convert this program into an hexadecimal file. So in order to convert this into an hexadecimal file, I am going to build this program. So when I press build, the program gets executed and it gets converted into an hexadecimal file. Now let us look at the hexadecimal file. So I have stored it in a particular folder. So here you can see this is my project file. Here I have an hexadecimal file. When I open this with a notepad, you can see the converted hexadecimal file. So this is the converted hexadecimal file. Whatever we have written in embedded C program, it got converted into an hexadecimal file. So this is the file which we will be importing into our Proteus 8 environment. So I right click on this IC, go to edit properties. So here I select the clock frequency to be 10 megahertz. then select that hexadecimal file. So the hexadecimal file name is my project. So I select this my project, open. So now I dump that hexadecimal file onto our microcontroller IC. So now we want to check whether our circuit is working properly or not. So we go and press the play button. So when we press it, you can see the LED is connected to port 0, lights up for 1 second and switched off for 1 second. The LED is connected to port 2, you can see it shows a combination of 0x55 and 0x AA. So the important thing to note here is the logic 0 to a particular port pin will enable the LED to glow. Logic 1 will disable the LED. So that is how we interface an LED with an AT89C51 microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.